Welcome to another video on my Raspberry Pi 1 running Raspbian Linux with a project programmed in Python. And the Raspbian is equipped with Serial Pi Plus board connected to a serial cable with on the other end a Minicom serial terminal. Then Raspberry Pi camera, raspicam, connected to the Raspberry Pi with a fischertechnik stand, and hidden here is a network cable for VNC, virtual network computing, and of course a band cable, which leads to this breadboard with some electronics and some fischertechnik as well, depending on the project. And right now the focus is on the Max 522, a digital to analog converter for controlling this LED. But last time I did, last time and the time before that, I also used this one, analog to digital converter, and I made a mistake last time by mentioning the wrong chip. It is the MCP 3008. Anyway, it is evolving and using SPI, the Serial Peripheral Interface Protocol. And for some weird reason, when I have used this version, which uses three-wire protocol, which combines input and output channel into half duplex, so data transmission goes over the same wire, but not at the same time. While this version, full SPI, is using two different wires for back and forth. Master input, slave output, master output, slave input are over different wires. Now the problem is as well, and that is where it goes confusing, when I start fresh with this one, it works. No hassle, no problem. When I then change to this one, it goes horribly wrong. The exact same instruction transfer ends with bad argument or something like that. Invalid argument. And it is basically the same protocol, I just use three-wire. So there is something with three-wire. And when it gets even weirder, when I don't use the ordinary Python program, but I use the Python shell. Then, for some reason, with this it goes perfectly fine, and with this one, either it goes immediately wrong or it goes right for one time and then it goes wrong. Information says that is because there is a problem in the firmware. That may be so, but not for SPI. And all the information that I have got is handling SPI, doesn't even mention three-wire. So I think there's only a problem with three-wire. And let me go to the software and show how things go wrong again, because they will go wrong for this one. How to solve it? I don't know yet. However, right now this is not connected. This is connected. So let's see how things go wrong, and maybe I can find a solution or have to stop it altogether. And that would be a shame. Because in the whole package that I received for project with my Raspberry Pi, it's there not for nothing. It is there. And you can use it with Python. So why does this go wrong? Why do they include the chip when it's not applicable? That is a nonsense redonation, a complete BS redonation. So it has to work somehow. And I just ended the last segment with the word redonation, which is not English. It's a Dutch word with an English and I should have said reasoning. Anyway, yeah, let's see what is on here. Well, first, of course, this one. If you've seen this video before, the raspicam up close. But seen from the other side. This is the analog to digital converter. This is then the digital to analog converter. This goes right, this goes wrong, and not at the same time. And this video stream has a delay of 3 to 4 seconds. With, of course, this 3 probes for clock, data and chip select, and that should be usable with 2 of the same things, 2 of the same kind of devices, and that goes wrong because these aren't obviously the same devices. They are not the same SPI. 3-wire and normal SPI don't work together, as it has shown. Almost the same view as master, as the former segment, but used with screencast. This is, let me name it. This is then minicom serial terminal, oscilloscope, and now I noticed something strange. Why is the clock on 1? No, it's a data that's showing 1. Yeah, it's data. Odd. This one should be ignored. It has no meaning at this moment. It's not connected. Anyway, let's run the program, and it will go wrong within some moments. Yep. Then I can use this one again, just for completeness sake. So not wiring Pi, that's a different thing. Okay, spidev. Yeah, I called spidev, but this is of course spidev. Yep. Then SPI open. Then defining the list with 255 and 0 alternating. 255 being a maximum value. Setting 3-wire is true for now. I may use it for 3-wire. No, I have to use 3-wire because it is connected with my MISO and MOSI connected hardware. This is okay. Now let's see how this is going, right or wrong. Yeah, right, it's going. then I have to say SPI close. Why do I have to use 3-wire? Because it is, like it shows here, it is connected. Using the wiring, it is this one. This one is connected. The connection. Ignore this one. It's this one, 5 to 2. And yeah, GPI is 3-wire. Actually, this is correct. SPI 3-wire. Actually, it's a strange idea, because this is output only actually. If you look at it, this one is in. It reads this fischertechnik LDR. It reads a normal electronic LDR. It reads an NTC, negative temperature coefficient resistor. This one controls an LED. So, in that perspective, it only sends. Anyway, let's find some more possible solutions, and otherwise it may be over, but why include a chip that won't work anyway? Strange. And there may be just a solution, although I have to change tactics, because I am right now using spidev, which was highly recommended for this one, and it does work. On internet I found one single post that says, why don't you use Pi GPIO, which you might read as pig PIO, but it is Pi GPIO, and I've used it before. So now the question is, where do I have it again? And I should have it. I have this one. I have spidev, and oh, I might have it in downloads. And yes, I have Pi GPIO. Which I have used for Pi scope in the past. I can still use it to accurately show what is going on. Let me just do that. No problem. Why here? I don't want you here, I want you here. So go to downloads, then Pi scope, and then run Pi scope. And there is something called Pi scope. I have to. Alright, let's do that then. wait, what did it say exactly? Pi GPIO, oh, I forgot the D from demon. So oh, come on. Where's the daemon? I know I have it. Alright, I have to dive into that because I know I do have it. But that's not the point right now. Although PiScope is very useful to use, very good to use. This because PiScope is looking on the Raspberry Pi which signals go where, and of course this oscilloscope looks at the outside. Always useful. Anyway, I should use PiScope, or no, not PiScope, Pi GPIO in here. And the question is then how to do that. So I need to be reacquainted with it. Another thing is this is C and I'm using Python, but it may be just a little reacquaintance. Okay, let's look. Okay, so instructions. First I have got PiScope running, which means that I have indeed managed to get the PiScope daemon running, and that is in here. So this one is running, then I made a few mistakes, then I got PiScope running, which shows nothing right now because there's nothing running, but you can see here everything from SPI, data, clock, C1, C0, MISO, mousy. Oh, and probably this clock instead of this one. Doesn't matter. I'll see soon enough. But also instructions tells I have to import Pi GPIO, and that means that I have to disable spidev. I have to do what? Well, actually SPI is this one, so I better have this one removed and move over to this. That means instantiating at the same location. That means that I now have to use spidev, SPI as Pi GPIO. This is the way they say to do, like here. Point is, however, when I want to use SPI write as instructed, this is not Pi GPIO, this is spidev, so that's confusing. I need, and let me check that for sure, Go here, select Python. And then select SPI. It says SPI write opens and writes. So I do have to open it first, of course. And it says simply open. Usually you have to use this. So let me do that. Then SPI write. You have to write something. So let's go here again. SPI. Oh yeah. SPI transfer. Handle data. And this is write. So the big question is which one to use. And this might be tricky. But I want you to use that somehow. Okay, what's handle? SPI open. Yeah, that means, or that could mean 1, 2, 3, 4, 5. The name or IP address running the PI daemon. Well, I have only one Pi running. Where is my, oh here. And mode. Right. Things are to be found out, which I thought I had, but then you find out you don't. This is everything. Go to Python. But I'm up here, I think. Okay. I had Pi interface, SPI. Right here. Open. Right, this was the explanation. 3-wire should be then this. No, not that one. Go back. I lost my... Oh dear. Okay. Nice. I lost my page. One bad click and you lose your information. Anyway, this should be SPI write something. So SPI 3-wire goes out then. SPI max speed should be there, but I'm not sure. And transfer should also be there somehow. Does this work? Well, let's do something else. Let's disable this one and see if it runs anyway. I don't think so. Who knows? So I am going out of here. Oh, and it is very slow now. Why is it very slow? Because I have a Pi scope running and I have, of course, this one running. And that slows down a lot. This one. This will give an error right now. Look at that. PI instance has no attribute open. then I will say SPI open. Takes at least 3 arguments, 1 given. Okay, need to find that out, but it means that open is not just open. Okay, so I tried some and I got a lot of errors first. Let's go downward a bit. First open problem, I solved that by opening one on 50,000, or is it, oh, it's 500,000, okay. 3 wire, attempt 2. Then I had to disable the 3 wire argument right here. Then it had no transfer to. Yeah, that turns out to be only transfer. Then it says exactly 3 arguments, which is a bit odd because it only shows 2. But I said, okay, if I have to use handle 1 here, why not handle 1 here? And then it says runtime channel is already in use. But there you go. And not just that, this happened as well. And on the oscilloscope it happened. So let's run it again. Hopefully it does it exactly the same. Look at this. I have to adjust but does this mean that it is working? Not really. Not really. Well, let's do it again. Okay, so on both scopes I have something, but what it goes around is here, and right now you can't see anything. Now you can. And can you see something here? Not a thing. Nothing. And it's gone already. So let me put this one a little bit down. Roll down then. Okay, I can close this, but I won't, because then I'm losing the program. Well, at least the editor. Let's do it again. And alright, I am missing a wire right here, so I have to put this wire also here, because I'm not quite sure which of the outputs of the chip is active. Let's do it again. And it may be weak and extremely fast, but I don't see anything. But at least I do have a very positive result on the scope, on both scopes. Oh, it has an attribute. Okay, yeah, that will be right this. Let's check again. Goes for 2000, so little patience yet. Almost there. SPI. Okay, that will be then 1. I don't care. But this is at least a result I can live with for now. I want that LED to become active, and that is not working yet. But step with Pi GPIO, I'm a step closer to the solution. And with this result, I wrap this video. Finally some results, at least on screen. So for now, it may have been boring with searching, but that's part of the deal. That's part of how you get things running. Thanks for watching anyway. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, always welcome. You can also follow me via Instagram and Twitter. Please donate to keep videos like this coming to you. And you can donate via PayPal and Wired. Please see my website for more information. And you can also become a patron and have your name mentioned on my website, and depending on the pledge you make also with my videos. This is obviously going to be continued. Have a nice day for now. Bye bye.